Okay, thank you. Thank you for the nice introduction. And thank you also for inviting me to talk here. I'm very honored and excited about it. So I'll be speaking about collaborative and community-driven projects and articles or papers. And actually, let's see quickly where the chat is, because I can post the link to the slides there. You can also see it on the screen. So some background about me. I worked in the industry before I started my PhD, which is also almost finished now. I just have to defend. And I, especially in the software tech industry where I worked for a couple of years, collaboration is the standard. And I used to work in teams, and you had goals together as a team that you work towards, and you can see your own output, and you're kind of motivated by the team effort. So when I started my PhD, and also from previous experience in my master's, I realized that it's very different often in research, and I'm quite frustrated by that difference. So this kind of lone ranger approach in academia doesn't really sit well with my goals. So in my PhD, I started actively looking for communities to work with and to collaborate with, and mostly in neuroimaging, but also a bit wider. And I have some things that I try to do that I don't always do well, but that influence or bias the ways in which I work with people. And it's all, for me, it's all about inclusion and collaboration and sharing our information, and not competing for it. So all of these aspects, I think, led me to some interesting projects that I want to give you a very high level view on today. And they're listed there, and those links are all to papers or preprints that describe these projects. But I will give you some insight into all of them, and then tell you a bit about how I experienced them and how I've learned from them, and how some reflections on how to get into these projects, what the incentives are for joining them, and also what kind of practical aspects are important when running them or when joining them. So there's the list. There's a few that I will explain here. So you have this NARPS project, which is research into the variability of neuroimaging pipelines. 197 authors. There's another second aspect, which is also research driven. So it's looking at consensus when we report our methods in neuroimaging and neurofeedback research. So both of these first two are research driven, and it's focused specifically on a field of research and their practices. And 84 authors, 197 authors, so there's a lot of people working together. And then we also have different types of themes. So like the Brainac community, which is more a community-driven effort, not focused on a particular type of research. This INOSC, which is International Network of Open Science and Scholarship Communities, something like that. Mostly coming from the open science communities in the Netherlands and how they work together. Another community effort that I've been involved in is the Organization for Human Brain Mapping's Open Science Room, which is kind of a unconference at their annual conference. And then finally, I have this open brain consent, which is more about research procedure and not research itself, but also a project that stemmed from a nice collaboration. And as you can see, all of these have large groups of authors. I mean, it's not like these physics papers where you have hundreds or thousands of authors yet, but we're getting there. And there's always been a core team of people that run these things. And I highlight their names there because they are the people that actually did a lot of the work in either establishing these communities or running these research projects. So if you want to know more about it, then those are the people you need to go to. I also highlighted in this table how I got into those projects and what my involvement was in the projects. So in some of them, I played a kind of biggish role, and some of them I was just kind of there and maybe edited a few lines or suggested a few changes to the paper or reviewed something. So the level of involvement definitely differs per person on these things. But I will tell you a bit more about all of these individually now. So the NARPS project, which stands for Neuroimaging Analysis Reproducibility something. I forgot, but the link that I put there can show you what it's all about. But it was essentially an effort to see how reproducible our results are when we have different analysis teams, in this case 70, testing hypotheses on an existing and same data set, but having a lot of freedom in terms of how they test these hypotheses, how they process their data, how they set up their pipeline to process their data. Oh, thanks, Sander, for posting the link. There was, as you can imagine, there was a lot of flexibility, especially in neuroimaging pipelines, where you have so many steps that kind of the different permutations of decisions that you can make end up being thousands and thousands of possible pipelines. And none of these 70 teams actually chose identical workflows to analyze the data. And this was then this was kind of exemplified in the variation of the results. So very interesting project, very interesting finding. And the cool thing about this project was that it was quite open. So you just had to have experience analyzing this type of task data, fMRI data, and it was advertised online on some what do you call it, chat rooms, on some mailing lists, and also on Twitter. That's where I saw it, and I said, okay, cool, this looks great. And what they also said that was a big incentive is that you can get a co-authorship on the Nature paper eventually if it gets published. So that really, like, you think, okay, I don't necessarily want to put in all of this time, but if I'm second year PhD student and I can get the co-authorship on Nature paper, it's not something that you're gonna say, stare in the face and say no thanks. So that was pretty interesting. Also, in this project, it was interesting that it was led by some groups that are well known for their work on reproducibility. So you get interaction with different groups that are kind of leading the field, which was a great experience. The next one was CreateNF, which is consensus on the reporting and experimental design of clinical and cognitive behavioral neurofeedback studies. Long description, and the consensus part is actually was the big challenge of this project, because in our field of neurofeedback, where I was working working on methods in real-time fMRI analysis. There's a lot of mechanisms in neurofeedback that's very poorly understood, and a part of it is actually hindered by or caused by very little standardization in the field when it comes to experimental design or reporting outcome measures for how you look at improvements based on neurofeedback studies. And like really bad reporting practices or just inconsistent reporting practices. So the literature is difficult to parse. It's difficult to put everything together, conduct a meta-analysis, for example. So the idea was here to get consensus on these things. And obviously for consensus, you need wide representation within the field. So you need to have collaboration of multiple researchers from multiple labs doing similar research. In this case, it wasn't necessarily, as far as I know, advertised the same as the NARPS study was. It's more that people were approached because of their involvement in previous conferences or the same topic. So it was more like a top-down approach than NARPS was. And there was a lot of effort into kind of just continuous discussions by email and filling in forms and coding the different ways in which people report their results. And then also to from that, to create an actual checklist and an application that people can use. So to reach that level of consensus was quite difficult. So this was a kind of different type of research project, but quite interesting. The next one I want to chat about is Brainac. And as Myrtle already mentioned, this is kind of in the theme of hackathons. But in the case of Brainac, it's not necessarily the standard like 1 day or 1 weekend hackathon or competitive hackathons. It's more a community-driven hackathon. So you work on the projects, you work together on something that someone suggests, and people are free to suggest any project they want in this kind of wide field of neuroscience. And sorry. But there's no competition, there's no winners. Everyone just reports on their progress on these projects. And the cool thing about Brainac, I think, is this kind of decentralized structure. So there's often this global Brainac event where people from all over the world gather in small groups to do their local hackathons, but it's coordinated globally, and people can kind of work together on projects from different locations virtually or attend talks that are hosted at different locations. So it's about talks and projects and being educated. So they often have these things called the hack track and the train track, where the train track is about getting guidance, attending workshops, and getting just kind of embedded into this community, whereas the hack track is more for people who want to work on something specifically. So for this project, the people from the community were actually invited by a journal to submit a paper that's kind of a refresher on what Brainac means and what the activities are. And the mindset here was also not coordinated as for the research projects in such a structured way. It's more like radically open, like anyone who wants to be part of this community can, anyone who wants to contribute to the paper can. And that makes it easier for people from different fields and people with different skills to contribute whatever they can contribute best, and then to be kind of to grow into the community together. And this was a big effort. I think a lot of time went into this. I was not part of the core team, which in hindsight I'm happy about, because the time that it took for those people to put all of this together was intense, but also the outcome is great. And the authorship aspect of this effort is also interesting, because there's something like 218 authors on the paper, but then also the community itself is included as an author. And then that link or ID or whatever the correct terminology is for citing that community, that links to a list of even more people that can sign up to the community and bring their own contributions. The next one was open brain consent. And if you are familiar with the GDPR and its the implications of GDPR for personal data like neuroimaging data in the EU, you would probably realize that the GDPR is quite has a big influence on how we share data in research and neuroimaging data, for example, where you can identify someone's face, or if there's behavioral data that goes along with these data sets. But it's quite complicated with the GDPR to figure out like what exactly does anonymous mean, how do I identify my data, etc., and can I share it somewhere, for example, a repository called OpenNeuro, which is located in the US, or can I not? All of these questions, and I personally encountered a lot of this with my PhD project. So at one of the Brainac community events, I suggested a project that says, okay, we have these things called, we have this repository called Open Brain Consent, which is there to help people figure out how to get consent from people to share their data, but it didn't account for GDPR peculiarities. So then I suggested a project and said, I want to expand this existing great resource for GDPR and see how we can perhaps improve the way that we help people share their data in the EU. So we did this Brainac project. It kind of, I was not expecting it to grow into something this big, because I just thought, okay, 1 or 2 people might want to just chat with me at the table. And because it was in Rome, we had some nice ice cream. So, but then actually there was a lot of people involved, and after that we had multiple follow-up sessions. Seems like a lot of people had the same challenges, and then we it ended up being these global discussions that we figured out some new resources to add to the existing open brain consent documentation. Things like data use agreement, templates, and also people translating all of these things in multiple languages. And that ended up in a summary paper that we wrote. Second to last is International Network of Open Science and Scholarship Communities. And for this, essentially all the open science communities in the Netherlands and a few other countries as well got together over a long period of time, discussing how we think, how useful and practical we think grassroots communities can be, and how we help each other kind of grow the use of open science practices in academia and research. And we actually got together in person, so it was quite a while back when it started. And then over time, virtually, we also chatted a lot. And that ended up in a paper to describe what the role of open science communities can be in wide-scale adoption of open science practices. And the last one I want to also just highlight is this paper, which is called Centering Inclusivity in the Design of Online Conferences. And we recently pre-printed this, and it's basically trying to give our personal experiences a platform, and also highlight resources that we think can add to inclusivity of online conferences, apart from the general improvement in accessibility that comes along with the pandemic, because everything is virtual, but it does not necessarily mean it's automatically inclusive. So this grew out of having built kind of an inclusive, or an attempt of an inclusive online experience in this OHBM Open Science Room, which I was the co-chair of. And then afterwards, we kind of collated all of our experiences, from the speakers to the attendees to the group who actually organized it. All of them contributed and wrote this paper. So I was involved in all of these things, and I have some reflections on them. And I think 3 points are worth highlighting, and that is, what incentives do we have to join these things? How do we actually get into these projects, and what useful lessons and approaches there are to run and complete projects like this? So I'll finish up with these things. Incentives to contribute. I think the thing I mentioned about the Nature paper is a big incentive for any researcher. People like citations, people like high impact factor journals. And if you can do something that's kind of part of your standard job, you don't have to lead the whole effort, you just do a part of it, and you get that I think is a plus. So there are incentives that fit into the current structure of how people do science. That's not necessarily a great thing, but it's still an incentive. I think another incentive could just be the fact that people might want to or prefer to collaborate rather than working on their own, and that could be a big driver for people joining communities like these. And the last one, I think, is just to say that people might also be morally or ethically driven to contribute to projects like this, because some or all of them focus on improving the way we do science in terms of transparency, reproducibility, collaboration, and bringing more diverse views to the front, which I think are all generally good things. And I think the absence of that is very stark in academia and science. So I think these could also be incentives on a personal level for people to join. And how to get into it, I think personally, the thing that helped me most get into it is just to be on Twitter. So you kind of get into Twitter, you're on social media, you follow people and you see these things come by as people retweet. Oh, there's the NARPS thing. Cool, let's click on it. Oh, it looks interesting. Maybe I'll join. Twitter is very useful for things like this, also to see new papers in your field and to be part of kind of also the hidden curriculum of academia, because there's a lot of interesting conversations that happens there. And there's a resource if you want 10 simple rules for getting started on Twitter as a scientist. Chat groups are useful if people want to go onto the Slack of the open science communities in the Netherlands, or on Brainac Mattermost, or in your own field, there might be some similar aspects, or mailing lists. I think those are often populated by these initiatives. Also, on conferences or hackathons, attending them also gives you exposure to these groups of people or communities that tend to lead these initiatives. And if they're open and inclusive, there might be an easy way to join that. I think in general, just sitting around or being passive does not help if your goal is actually to be involved in these things. So it requires some effort on a personal level to join. But some communities really make it easier than others. Lessons learned. I think for all of these projects, there were always a small core team to coordinate the big effort. And for some of them, it's actually a lot of work, and it takes over their existence for multiple months or weeks, or yeah, let's say weeks or months. But doing that can also be very rewarding, and it can give a lot of exposure to the community itself. I think being the co-chair of the Open Science Room at the Organization for Human Brain Mapping conference did a lot for me personally. So if you're into that type of thing, I would recommend it, but take care. Don't do overwork. Take care not to get overworked. I think during running these projects, it's good to use tools that promote accessibility and collaboration, and not weird, obscure things that most people will not be familiar with. So Google Docs, Google is not great, but Google Docs are great for collaboration. And selecting a chat program for like real-time communication is also useful. And then I think it's important that if people want to lead these things, consider designing it for inclusivity. So from the start, actually think about how people might be or feel excluded from the project, and try to correct that upfront, or at least make an attempt to do that. Another thing that we also found is it's useful to discuss authorship upfront, because that's important to researchers. Not necessarily to all of them. And in the case of this community authorship, that's a model that I really like, because it takes the focus away from individuals. But in some of these cases, yeah, authorship is important. So first author and who's last author, and where do the first group fit in on all of those things. That's an important aspect to take care of. Sometimes also you're part of these big projects, but you don't necessarily have to get a paper out of it. I know we deal in the currency of citations, but sometimes it's probably useful to think like, do we really need to write a paper or not? And for all of these things we did. And at some point in some of them, I thought, okay, should we be writing a paper or not? I'm glad we did in the end, but it's a lot of work. And then lastly, I think the lesson is that I want to bring across is that grassroots initiatives can change a lot. I mean, they can change the system a lot, and they can help. Like I think is exemplified by all of these examples that I mentioned. But also top-down support is often required and useful. So in the case of the NARPS, or the variability in neuroimaging pipelines paper, there was a lot of support from big labs with access to funding and with access to prestige that led it. And that got a lot of people on board. And in the case of some of the grassroots open science communities, there was also support from their local institutions to give them funding and time and support to make these things happen. So I don't think, I think grassroots initiatives can achieve a lot, and they should irrespective of whether they have top-down support, but top-down support is also useful, I think. Thank you, everyone. That was my presentation.